Hello GCSE competing students, another video by Mr. Holmes. This one deals with algorithms and in particular we're going to talk about today the searching algorithms, and we're going to look at the linear search, how it works, and the binary search, how it works. In my next video we will take those ideas and turn them into code. What you really need to understand, however, is how these algorithms work and to be able to trace them. Right, so without further ado, let's get on to it. So searching is going to take place over either a string, a list, or 1D array, or a 2D array. Okay, it's going to be a collection of items, and all it is, it's traversing or going through. I'm going to talk about lists. It's traversing that list and locating a matching search element or an item. Now there are many versions of linear and binary searches, so the ones you may see in textbooks might be a little different, but the basic idea is the same. And for our example, that the ones that I'm discussing, I'm going to assume that we're going to return the index, that is the position of where the matching item has been found, and I'm going to assume I'm going to return the first one that I have found, and then the algorithm is going to stop. Now there are variations on what you do with this, but I'm going to assume that we're going to find a matching instance and then stop, or if we don't find a matching instance, we're going to return -1 as the index item. And that makes sense because the first index item is always going to be 0, whereas -1 would not be a possible search item. That kind of tells me that I have not found what I'm looking for. Now, right, moving on now to the binary search. Now the binary search here, I have exactly the same list as I had before. However, you will notice that the list is now in fact sorted, and it is in fact sorted in ascending order, meaning going from smallest to largest. Now in the binary search algorithm, there are many ways of implementing it or writing it down, but we're going to go with this assumption that I have a head marker which marks the beginning of where my search area is for the number I'm looking for, and the tail, which is the end. So the head is the starting point, the tail, or T over here, the marker, is the tail point. M is the midpoint. So what we do in every single case is we're going to say, right, I'm going to examine the element in the middle. So I start with my head at 0, I start at the head at the tail at element number 7, or the last value in the list, because I still have to search the whole list at this point. So I begin by looking at the element which was midway, so which we calculate by always taking the head plus the tail positions and dividing them by 2, do integer division by 2. So in this case it would be in fact element 0 plus 7 is 7, 7 div 2 is 3. So my M marker, my midpoint, would point to element 3. And again, as before, I'm answering the question, is that well, sort of like the linear search, but instead of asking is Lx, I'm now going to ask is Lm equal to 5. Is Lm equal to 5? Lm is in fact equal to 3, so it does not. However, so I have a fail, but unlike the linear search, I can now use the fact that this is a sorted list, so I can automatically do a whole bunch of cool stuff. I know that the number I'm looking for is 5, and I know that 3 is less than 5, which means automatically all the numbers to the left of the number I've just looked at can be dismissed. I can chuck them away, I don't have to look at them. So my searchable area now becomes the value of the midpoint plus 1. So I just move the head 1 position to the right, and now I have to recalculate the midpoint. Midpoint is now h plus t, so h is pointing to element 4, t is pointing to element 7. 7 plus 4 is 11, and whole number division by 2, midpoint of 11 divided by 2 is roughly 5. So now we're going to be examining and say, right, is element at position 5 equal to 5? The answer is no, it's not. Okay, all good and well. However, the number that I was looking at is in fact a 6. So I know that the 6 is in fact to the right of the number I'm looking for. So it means I can pull the tail in and put the tail 1 to the left of the midpoint where I've just searched. So both the head and the tail now point to 4. 4 plus 4 is 8. 8 div 2 is in fact still 4. So the midpoint will now be calculated and be pointing exactly to itself again, to the 4 as the head and the tail are. Is L4 equal to 5? The answer is yes, it is, and I've now found my matching element, and so I will therefore return the result. Aha, I found it at position 4. Now, that's all good and well. What happens instead? So let's reset this to where it was, kind of, at the first time we did the search and we had our first miss. Let us suppose instead of searching for 5, we were now searching for the value of 4. So my test is now going to become, is the value at position M equal to 4? So my first hit would be exactly the same place, and 3 is less than 4, and therefore the head would be moved on to look at the next position. So the head and the tail would be as it was before. The midpoint would now be calculated as 4 plus 7 is 11. 11 div 2 is roughly 5. So the midpoint would now move to the 5. And I'll be asking, is L5 equal to 4? The answer is no, it's not. And also I would know that, 6 is bigger than 4. So that in turn would mean that I could dismiss everything to the right of the midpoint, just like I could dismiss everything to the left. So the tail would now have to move to point to there. And I can also dismiss this one because it's not equal to what I'm looking for. So we continue with the algorithm. Head and tail both now pointing to element number 4. And 4 plus 4 is 8. 8 div 2 is 4. So the midpoint would actually point to element number 4. And element 4, is element 4 equal to 4? The answer is no, it's not. It's equal to 5. So that in turn would also be a miss. And the algorithm would basically say, okay, I know that 4 is, sorry, I've just looked at a 5. So I know that the 5 is bigger than what I'm looking for, so I can move the tail one to the left of the midpoint of where I've just searched. And you can see what has happened now. The head and the tail have overrun each other. And when that happens, that is a situation where we go, ooh, we've not found what we were looking for. That situation can only happen when I've run out of elements to still search. The head and the tail have gone past each other like two ships in the night. End of algorithm, stop. That is the end of a failed binary search. Thanks for watching. Please study these algorithms, watch them again and again, make up your own, practice tracing them, practice going through them. It's very important. You will probably be asked one of these at least. If not the searching algorithms, you certainly will be asked the sorting algorithms, which I'll cover in a later video. Mr. Holmes signing out. Thanks for watching.